Alright, this is a screencast on how to do the Sunspot graphing assignment. Now, you just did a graphing assignment, scatter graph, uh, where you did a line of best fit for some data that we got from one of our labs. And so now we're going to try and, with a little less instruction, to have you that now make a more complex graph using this data below. Now, it's a Sunspot data set, and it has the year starting in 1945, and then the average number of sunspots that are on the sun during that year. Now, you might be asking yourself, what is a sunspot? So, if we go quickly to this definition here, it says sunspots are temporary phenomena on the photosphere of the sun that appear visibly as dark spots compared to surrounding regions. And here you can see these sunspots on the sun. Obviously they're using a filter when they look at the sun, and that's what allows you to see them. They correspond to concentrations of magnetic field flux that inhibit convection and result in reduced surface temperature compared to the surrounding photosphere. So basically what that means is that due to this changing in the magnetic field on the sun, it's going to stop convection and make those areas cooler than the surrounding areas. If you are asking yourself what is convection, then I'll show you that real quick. Convection is heat transfer by mass motion of a fluid, such as air or water, when the heated fluid is caused to move away from the source of heat, carrying energy with it. Convection above a hot surface occurs because hot air expands, becomes less dense, and rises. So here if you look, you can see, let's say this is heating some water underneath. Then this water at the bottom is going to get hotter. And as it gets hotter, it's going to become less dense and start to travel or move up. Well, as it moves up, it's going to get further and further away from the heat source, and it's going to start to cool. Then as it cools, it's going to become more dense again, and then it's going to fall back down where it's reheated. And this creates what we call a convection current. And it's going to cycle around all throughout the liquid or the gas. Now, the way that you're going to do this data set is pretty straightforward. You're going to have a spreadsheet that's already created for you, but it's going to be blank, but it's going to have this assignment name and your name on it. And you're just going to need to make two columns, one for the independent variable and one for the dependent variable. So the independent variable, the thing that they're deciding to change, is time. And it's always good, even in the data table, to put down it in parentheses, years. And then what are they counting or measuring in this experiment? It's the number of sunspots. Well, specifically they say average number of sunspots. All right. So now you've made your two columns. Now, a nice little thing that you can do here, just a hint, is when you come up here, if you want to get this to where this whole column is that size, you just come up there and double click it, and it'll automatically make that to the size of the largest thing that you've typed so far. Here's your hint. We're going to start in 1945. And you could then start hitting 1946, 1947, 1948, but that's going to get a little bit laborious. So all you have to do is first put in 1945 and 1946, and then highlight those two columns. And then the computer knows when you come to this little corner, see this little blue corner or square? When you come to that and then you drag it down, all right, it's going to know, it's going to repeat that pattern of adding one every single time. And we need to go to 2013. So you just keep dragging it down until you get to 2013. and then you've all filled out all of your independent variable. Now all you'll have to do is go through and type in the numbers that the worksheet has. When you do that and you finish that, it's going to look something like this. All right, you'll see, and I didn't label this the same in this one, but this is the one I was just, and you'll have all of these numbers typed in. And a quick way to do that is once you've typed in the number, let's see, what is the first one? We've got 32 and 100. So when you type in 32, you just hit enter, and then it'll go down to the next one. And then you just type in the number and hit enter, and that actually doesn't take much time at all. And then from there, remember to go over and hit your insert chart button. And this time, what I want you to do, I'll go ahead and do that here. What I want you to do is your chart types. This time you're actually going to do a line chart. So you'll click on that. Now, when it does this, it's going to give you a weird look at first. All right? So what you'll need to do is come in and hit your use column B as labels. And once you've done that, you should be okay. Although, let me make sure that that's the case. Yeah, I think. Okay, I checked that with another graph, and you will need to make sure that these two bottom boxes are checked to get the single line. Now, it won't look like this. Obviously, you're going to have quite a few sets of data all the way from 1945 to 2013. Now, notice it automatically gave this a title, but this won't work for our title because it needs to be the effect of the IV on the DV. Thinking back to what we said was the independent variable, which was the time or years, right? And the dependent variable, which is the average number of sunspots. Now, it looks like it automatically labeled this properly and the y-axis properly, so that's pretty good. Don't forget to, since there's only one line, to go ahead and take out the legend, and then you should have it. If you have any other questions, you'll just have to ask those in class or refer back to the previous video to see how to do some things if you forget how to do them. But hopefully you can remember, and you'll be able to come up with a really nice graph with a lot of data in a very short period of time.